Testing. What's up? I'm Jacob Blitzo, your Elixir Mentor, and welcome to another exciting episode of the Elixir Mentor Podcast. This is where we discuss everything related to Elixir, from interviews with enthusiasts, pioneers in the community, to innovative projects and libraries shaping Elixir's future. So let's go ahead and get started. Today, I'm thrilled to have Sean Moriarty joining us. Sean is the author of Machine Learning in Elixir, a book that explores AI and machine learning using Elixir. With a background in software engineering, Sean has been the forefront of the Elixir machine learning community, contributing to libraries like Axon and Nx. His book aims to be a comprehensive guide for Elixir developers looking to incorporate machine learning into their projects. So, Sean, welcome, and thank you so much for joining us today. Can you just go ahead and introduce yourself a little bit?
Yeah, sure. I think that was a pretty good introduction. My name is Sean Moriarty. I am the author of Genetic Algorithms in Elixir and Machine Learning in Elixir. And I have been sort of in this like Elixir machine learning ecosystem since the start. I worked with Jose back in October of, I think it was 2021 at this point, maybe it was October 2020, on the original like implementation of Nx and EXLA and sort of got that all kickstarted. And I've been involved with the ecosystem pretty much ever since.
That's awesome. What kind of got your radar onto Elixir at the start? Like when you started what was your first book called? The genetics?
Yeah. So the first book I wrote was Genetic Algorithms in Elixir. My Elixir story is kind of funny. So I was like relatively interested in like just like programming and like building applications and stuff since I would say like probably middle school. I think I started programming when I was like 13 or 14. And I started with actually, I think it was PHP was the first language that I like had learned, quote unquote. I had no idea what I was doing. I was just like randomly, I would Google things. Like I remember I spent like probably 3 or 4 months trying to teach myself PHP. And I had seen like HTML. So I was like, okay, like HTML is made up of tags, like, entities or whatever. And so I assumed that every single programming language was like that. So I was like, okay, everything is like this XML, like markup language based. So in order to teach myself PHP, I need to like memorize all of the like PHP tags. And I had no idea what like a function was, didn't know anything about control flow. I was kind of just like flying blind. Ended up going on a detour into like Cold Fusion because Cold Fusion is like a markup based language. And so I was like, okay, this is the coolest thing ever. Anyway, I eventually like sort of figured it out and had been like just dabbling, building like web-based applications for a little bit. And I was in college, and in college we actually learned Scala. That was like the programming language for like every single class at the school I went to. And so I had like become a little bit familiar with some like functional programming language like concepts. I think like Scala they call object functional. Because you can do like OOP and like I think everything in Scala is an object, but then you can like do a lot of like functional things with it. And so I was looking for like other languages that might be interesting, and I read Quora a lot. And so I like one day was looking on Quora about like different programming languages, and then someone had answered a question about what the best programming language to use for building applications was, and they had said Elixir. So I ended up just checking it out, and I was like, okay, this is pretty cool. And I built a couple of like small things in Elixir. I have a story on my Twitter that I think if people go back and find it about one of the first like applications I deployed with Elixir and Phoenix. I'm not going to bring it up on the podcast, but you can go find it on my Twitter feed. It's a funny story. And I was just interested in the language like from then on. And yeah, that was pretty much my start into Elixir.
What year was that about?
That would have probably been 2017.
Okay.
I think it was like the summer going into my sophomore year in college.
Okay.
And I had picked up I think I'd read Programming Elixir. I think I read Programming Ecto. And then I think I also read like the Phoenix book as well.
Okay. Yeah, those were probably first on my list too. And then the In Action books as well.
Yeah. Yep. So I think I ended up reading Elixir in Action after I had read the first 3 there, and then I kind of just I dabbled. I didn't do much like in terms of like open source work or anything. Like I would pick up a project. I was in school, so I was pretty busy, but if I had free time, I would pick up a project and just kind of mess around. And so I didn't start contributing to the open source ecosystem, I think, until like 2 or 3 years later. I got very into sports betting, just because like a lot of my friends were doing it. So I was like, okay, let's see, what this is all about. And I was interested in like programming and
we
math.
now know what you do with machine learning.
Exactly. Yeah. And so that actually is where I got introduced to genetic algorithms. So genetic algorithms are like a form of like optimization. It's like you could probably call it like black box optimization. So like in the optimization world, there's like a bunch of methods for optimizing like classes of functions, and certain classes of optimization problems are like intractable or essentially like impossible to solve perfectly. And so there's these class of methods that are like black box methods that rely on like sort of like a randomized or guided search, and genetic algorithms are in that class. And they're actually, they have been like academically studied for use in like portfolio optimization. So if you imagine like putting together like a portfolio of stocks, and trying to essentially maximize reward, minimize risk. So you sort of like solving that optimization problem. And it turns out you can also use the same sort of like portfolio optimization techniques for sports betting, because picking like essentially a winning portfolio of bets is very similar to picking a winning portfolio of stocks. And so that was where my interest kind of came from. I wasn't actually using it for anything practical. It was like purely academic in nature. And then I got the idea for the book. I wrote this open source genetic algorithms library called Nx, still on my GitHub. I haven't maintained it in like 4 years. There's a Nx based one that Jonathan Klusko did for his master's thesis. I think maybe it was 2 or 3 years ago. That is much better than what I had put together. And I had this idea that maybe other people would want to like see this, like be interested in this. So I sent it off to the Pragmatic Bookshelf, and Dave Rankin, who I think is now the CEO of the Pragmatic Bookshelf, or was for a little bit, was very kind and kind of walked me through how we could turn my idea into something that people would actually read. And I guess you could say the rest is history now.
I love that. What actually made you want to write a book, though? It's a big undertaking, especially in like such a fast pace. Like, I feel like you chose the hardest area of tech to stay relevant in for very long.
Yeah. So I don't like, I actually really don't know what like possessed me to write a book. I was also on like summer break at the time, and so I was kind of bored and didn't have anything to do. And I had assumed that I would like be able to finish it quickly, and then I started I was right before my senior year of college, so I started my senior year of college, and like had to finish writing this book, which was just like a complete nightmare to go through. But I've always kind of enjoyed like technical writing, because I don't want to say I don't like do technical writing for like other people. Like, I guess there is a sense of like liking like helping people, but I kind of write like selfishly, because I feel like I don't understand something unless I can like teach it to someone or explain it to someone. And so like technical writing to me is more of like an exercise in my own understanding. And so like going through that process of like writing a book was, I would say, like a very informative or very beneficial experience for me, just in terms of like helping me understand concepts a lot better.
No, I get that completely, because you can use technology and write code and build projects, and then the second you realize you have to explain it to someone that doesn't understand it, it takes you to the next level of understanding it.
Yeah, exactly. Yeah. Like, there's a good book, it's called Made to Stick by Chip Heath. And they talk about, maybe I'm confusing my books, but they talk about something, it's called the curse of knowledge, where it's like I think there's like an experiment where they talk about like people humming songs or something like that. But essentially the whole idea is like you have all of this knowledge in your head, or assumptions, and trying to get that out to someone that does not have the same knowledge is much harder than you would think. You have to truly understand something to actually like explain it to somebody.
Well, even like last week talking to Zach Daniel, he was saying that it's very difficult for him to teach beginners because he's just in the thick of it so much So like he's like usually other people can explain the Ash framework better than I can. And
Yeah, yeah,
like
no,
I get that too. Like if you're in the deep weeds of a framework, your assumption of what people know is way different than someone just taking a look at it.
absolutely. Yeah, I think Jose says this a lot, that he gets a lot of the Elixir documentation from like the questions that people ask him, um,
Mm.
because you write your documentation like from the perspective of like what you think people would know. Like if I was coming into like Axon, for example, I write the documentation like from the perspective of someone who had learned deep learning like Python originally, and it was like I'm answering all the questions that I had about like PyTorch and TensorFlow and all those frameworks, like about Axon. But I don't necessarily have the perspective of someone who is coming in with like no experience at all. So it definitely is a challenge.
No, yeah, I get that. When I start doing my machine learning journey, I'm just going to broadcast it all so everyone can see how how I learn and explain things because it's not pretty, guys. But um, when you like, what advantages did you see like as you were learning Elixir? What made you want to go like all in on Elixir with machine learning versus like Python or another language?
Um, so like I didn't at the time. I didn't have much like practical, like hands-on experience. I would say with like production environments and like software, like working in teams and everything. I just really I liked the language a lot, and I thought like a lot of the concepts just like clicked with me like very quickly, um, and I think my like appreciation of the language has grown over time as I've like gained more experience as a developer. But initially, it really was just like I ended up picking. I think I picked the language up like relatively quickly because like I said, I think a lot of the concepts just like clicked with me pretty early on. And I think that was partially because I had been like doing some functional programming like previously, so I kind of like understood how everything worked. Um, and I like I never I guess I think a lot of people reach out to Elixir and like Erlang and OTP for like a pain, like they have a need. And
Hmm.
I didn't necessarily come at the language from that perspective. Like I wasn't dealing with a problem at work that like could benefit from using Elixir. Like I just found the language and thought it was awesome. So I pushed forward on it. I'm not just now starting to appreciate like, oh, these are actually like some pretty awesome benefits to it. I'm happy the language did stick to me, but like I said, I'm just seeing the benefits now.
I'm kind of the same way. I had a buddy that kept recommending it to me over and over, and I was like, "Yeah, I'm sure it's awesome. I don't have time to learn it though." And then I had a project that gave me a reason to learn it, but I still like naively didn't really know. Like I didn't understand gen servers. I didn't really understand processes, but I started to fall in love with the syntax. And once you know, like coming from an OO background, once I like liked the transforming of like immutable data and like just how a functional paradigm works, I was like, okay, I like this. This is how my brain works. It's way easier than object oriented.
Yeah.
And then like only like as I started learning more and more did it become aware like how amazing like Erlang and Elixir are.
Yeah, I try to push like Elixir on all of my friends, and they're probably like annoyed at this point that I keep doing it. But I have had a few of them like have like the moment where it clicks, like they've learned like other languages like Python or JavaScript, and then like every once in a while, like as I'm like forcing it on them, something will click for them, and they'll be like, "Oh, this is much nicer to do in Elixir than it was in this language."
Yeah.
Yeah,
I definitely push it on people. I mean, I started a YouTube channel about Elixir, so
yeah. I try
it's
not to
the
get involved in the language wars as much. Sometimes I do, but I try to stay out of it as much as possible.
yeah, I don't want to either. That's too much for me. What kind of like with like the major hitting points of Elixir? We have concurrency, fault tolerance, and then the scalability. How does that help leverage like machine learning and just the whole LLM thing and everything involved there?
Yeah, yeah. Uh, so I think like everyone's initial impression of Elixir, like when you hear about like how well it does like concurrencies, like oh that would be really good for like doing like processing, like number processing. And obviously that's not like necessarily the case because the beam's not optimized for that kind of like parallelism that's involved in like neural networks and whatnot. I think one of the major benefits of like the fault tolerance, scalability, et cetera, is like, I think it's like from a deployment perspective, not necessarily like an actual like machine learning perspective. Because like a lot of the benefits we get in terms of like, or a lot of the speed ups we get in like our ecosystem for like doing machine learning workloads, it comes from like the C and C++ and like native programming language, like land. And those are the same sort of like speed ups you would get from like using Python with like PyTorch and TensorFlow, because we're using essentially like the same compilers and the same backends. So like the benefits you get from from using the language are just the benefits you would get in like a normal application too. So I would say like for machine learning specifically, there's not necessarily like a silver bullet. It's really more so like using Elixir to do machine learning like simplifies like I guess your application like development lifecycle. Like I can do machine learning in Elixir. I don't have to use another like service to implement some of these things. And I think there are other benefits too, like functional programming and expressing machine learning like models and workflows is I think pretty straightforward. Like the I guess how everything maps together just makes sense. Like I think all of the machine learning like literature, it's described in sort of this like mathy functional way, and I think it kind of like maps really well to what you can do in Elixir. And there's obviously like the like data processing and building like robust like data processing pipelines. So there are a lot of benefits there, but all of those benefits are, I would say, like adjacent to machine learning and not necessarily explicitly machine learning, if that makes sense.
Yeah, that makes sense.
Maybe not the best like argument or sell for the language, but like I guess choosing to do machine learning in Elixir, you get the benefits of Elixir, not the benefits of machine learning in Elixir, if that makes sense.
Yeah. Okay. Now, are there any like apparent like limitations, like with like computational power and like things like that? Because I know you have your like stacks like Discord where they'll integrate Rust and stuff into it for like heavy mathematics and computation and like GPU usage. Is there any limitation that you run into with just sticking with Elixir?
So we're talking about ceilings. I think that's a funny joke here. No, there really is like no like inherent limitation, I think, to using Elixir for machine learning. There are like right now implementation limitations, like from the perspective of like we don't have certain things just like implemented yet, but there's no actual like boundary for us to like that's limiting us from implementing some of these things. So like there's some good examples, like quantization is like I think it's a technique for like essentially like compressing the size of a language model's weights into like a smaller precision. And we don't have that implemented yet. And so that's like kind of like a limitation for using some of like the bigger language models on certain hardware. We don't have like parallelism or I guess it's like partitioned compilation for language models. So like splitting a language model across like multiple GPUs. We don't have that implemented yet. But we use the same compiler ecosystem that like, JAX and TensorFlow and PyTorch. We're using the same tools that they're using. We just haven't actually like implemented those features in our ecosystem yet. So there's no like fundamental limitations. It's just like we're 10 years and $1 trillion behind.
Yeah. No, that makes sense. Now, like as I was reading through your machine learning and Elixir book, you do a great job of like introducing tools, I think, in like a very like building process, right? You introduce simple things and you slowly grow into things. What are like some of the key libraries and tools that you discuss in the book? You talk about like Nx, Axon, Bumblebee, and like Explorer. Can you kind of go into what some of those are and what you use them for?
Yeah. So if you think about the Nx like ecosystem, you kind of look at it like almost like a pyramid. So you have like Nx is at the very bottom, and that's like the foundation of a lot of the libraries in the Elixir machine learning ecosystem. And that implements multi-dimensional arrays, or tensors is what we call it, and like automatic differentiation. It also implements like behaviors for doing machine learning compilation. And then we also have an actual implementation of a machine learning compiler called EXLA, which uses the XLA compiler, which stands for Accelerated Linear Algebra. And that's used to be a Google project. Now it's actually maintained by like an open source committee, which has been very beneficial to us. And then on top of NX, you have these like specific machine learning libraries like Axon, Scholar, and I think there's a few others that I don't know why I'm drawing a blank on. I used to know like every single library that was out there, and then libraries keep popping up. You have Axon and Scholar, and these like actually implement the machine learning methods that we talk about in the book. So Scholar is like traditional machine learning methods, and that's everything minus deep learning. That's like SVMs and nearest neighbors and all these different traditional machine learning algorithms. It's analogous.
Can you talk about those a little bit for us?
Yeah. So when I say traditional machine learning, that might be like a bad way to put it, but before this like deep learning revolution, and I think it started in like 2012, people were exploring a bunch of different ideas to like make machine learning work. And so everything that's involved in traditional machine learning is like, that's essentially everything that's not deep learning. So Scholar is like a very large library that covers like a lot of different machine learning methods that don't make use of neural networks.
Okay.
And then Axon is everything neural networks.
So when you say neural networks, that goes into the deep learning category, and like how does that kind of work from a very macro view? We don't have to get too deep. I'm just
yeah. So like I like to call deep learning it's like hierarchical transformations or like compositions of inputs, and then like you transform inputs in a way that they map to an output. Because that's just, like it's probably a terrible explanation, but I'll get there. Don't worry. So if you take an input like a representation, or like let's say like we have a representation of handwritten digits, right? So like a 1, and that representation is like grayscale. So I have a number that represents the like brightness of every single pixel in this image. This is like the MNIST data set is 28 by 28 by 1 grayscale images of handwritten digits, right? And so I have like all of these pixels, and I want to pass this through a function and then map that output to the actual like digit that those pixels represent. So the way deep learning does this is it just I essentially compose layers, which are transformations, and I will train a function or teach a function to map those pixels to some classified output. It's called like so I always got confused when I was learning about this, like why is it called deep learning? Because you could have like a neural network that's like deep, but it's only one layer deep. And I read an explanation. If you actually like, if you look at the computation tree, or like the actual transformations that an input is going through when you're doing like an actual like deep learning computation, that actual network is deep. So it's not necessarily like the amount of layers you have that makes it deep, which I was confused about when I first learned deep learning. I don't know if anyone else had that misconception, but yeah. So you essentially send these inputs through a bunch of transformations, and you get like a classification out. And then when I'm going through this training process, I'm essentially looking for like, how can I correct the network? So if I give it a picture of like a 1, I pass it through a bunch of transformations, and these transformations, like each one has a bunch of parameters that I can update. So, I pass it through, and let's say it maps it to a 2. Then I can look at how off I was, and then I can use that sort of like that feedback for how incorrect my response was, to then make a correction to the parameters that I have, and then send it back through. And so you do this.
Is this kind of like, is this how you would be training a data model then, essentially? Or
yeah, so that's what the training process is. So that's called gradient descent.
Okay.
And so it's this just like long process of passing inputs, getting outputs, and then taking the gradient of, some loss function or objective function with respect to my model's parameters, updating the parameters, and then repeat the process.
So you're repeating the process till you have an output that you're happy with.
Correct. Yep. Or until you run
Okay.
out of data.
Now that's you said that's gradient descent.
Yep, that's right.
Okay, and then I'm gonna just throw some words out that I remember.
Yeah.
What, like, when you're talking about like tensors and things, what does that mean?
Tensors. Yeah. So this is like a very contentious discussion between mathematicians, physicists, and computer scientists.
Okay.
It's kind of like the if you're like familiar with C++, C++ has vectors, and then like if you've like taken a physics class, there's vectors in physics and there's like vectors in math. So it's pretty much the same exact thing with machine learning. Like the word tensor, I don't actually know what it represents mathematically. Like mathematicians have their own definition of a tensor. In our like parlance, our like machine learning in Elixir, it's just a multi-dimensional array, or you can kind of think of it like a list of lists.
Okay.
So a tensor is, you could literally just say like a list of lists. It's some numerical representation of, usually some real world object that has multiple dimensions. And there's, it has different data types. You have like floats, integers, etc.
Okay. And is this like binary data, or like what is it?
So it could be anything. Like I think part of the challenge, like it actually maybe all of the challenge when you're doing like machine learning problems, is trying to find a good representation of your data. Like asking yourself, how can I take an image and represent this numerically? How can I take text and represent this numerically? Essentially taking like real world data, how can I represent that numerically? And that, like, the process you go through, or like what you end up with, is a tensor in the NX ecosystem.
Gotcha. Now, if you were to if you're applying this to like a real world project, what are the steps? Like, I don't know. Let's figure out a problem. Well, do you care if we use your example from like your book, your opening chapter?
Yeah, I think that was is an MNIST.
You're doing like the iris.
Oh yes, iris. Okay. See, I can't even remember what the first chapter is.
So you open the book up with the iris example where you're classifying a flower, right?
Yep.
So how do you when you start, you have your problem set, right? How can you go through your steps of like what frameworks and tools you use to get the outcome that you need?
Yeah. So it's like highly situationally dependent, but I think like there's like a very, I would say, distinct process you could take for solving any machine learning project. And I think if you pick up the book Deep Learning in Python by Francois Cholet, which was like one of the first machine learning books that I had read, I think he talks about this too. It's like either an 8 or 9 step process for training like machine learning models, and specifically deep learning models. I don't know if I'm going to get all the steps perfect, but I can just walk you through sort of like how I would solve a machine learning problem. So the first question I would ask is like, do I even need to use machine learning to solve this problem? So if I have a bunch of data, like a good example of this, like let's say I have a bunch of tweets, right? And I want to figure out like what country a tweet originated from or something like that. Like I could ask myself, do I even need to use machine learning to solve this? Like, could I just say like figure out what language a tweet is in and then naively map that to the country that speaks that language the most, right? And so there are a lot of like examples where I could probably come up with like a clever rule to outperform machine learning, and it'll just work well enough. And so that should always be your first question, is like, do I actually need to use machine learning to solve this problem? Or can I come up with something clever that will outperform a machine learning model, or do just decently well enough and be significantly less expensive to maintain and deploy? After that, if you say yes, the next step would be to get some training data. So the example, like the iris data set, that's one where there's obviously a bunch of like publicly available data sets online. But if you're solving like a machine learning problem in your company, then getting access to like good clean data for any sort of like machine learning model should be like your number one priority. And that's usually the step that people have a very hard time with, is like, how can I collect enough data to solve the problem that I'm trying to solve? And companies that like succeed at deploying machine learning models usually just have a really good like they have a really good like implicit data collection process, either implicit or explicit. And like a good example I always give of this is like, you solve like the Google captchas that are like, identify crosswalks. And I think there's a good like XKCD about this, but that's a good example of like a very I would say like implicit feedback cycle, where like I am labeling data for Google, but also like it serves like a purpose for them in terms of like as a captcha. And so like captchas are like a great example of like building in these sort of like data collection processes into your own processes. Once I have set up this like data capturing pipeline, then I would actually like get out a bunch of data, and I would probably throw that into like a Livebook and take a look at the data that I have with something like Explorer. And so Explorer is like a data frame library. So it's like exploration, transformation. Explorer is a library that's probably useful to everyone, regardless of if you're using machine learning or not, because it gives you like the ability to visualize, analyze, and transform your data in ways that, like, even if you're using machine learning or you aren't using machine learning, is very useful. So I would probably go through like an actual, I would say like a data exploration of the data that I have. And once again, like going through a data set, asking myself, like, is it necessary to use machine learning to solve this problem? Like, is there a very simple relationship between all of these input variables that I have that I could use to actually like make predictions from the data? Once you go through like that sort of exploration, then you have a process of like cleaning the data. So that could be getting rid of outliers, or like transforming the data in certain ways to make it more amenable to training. So like some data, you might have to get rid of some columns. You might have to discretize or categorize some columns. So like if I have a column of like strings, for example, that represent like the color of a leaf in like a flower, I might have to turn that into an integer in some way. And then I would actually go through the model selection process, which is like, what type of machine learning model should I use? And I could use, like, let's say just doing a simple linear regression, which is like one of the simplest, like most fundamental types of machine learning models. I could decide to train a neural network. I could use a decision tree. These are all different types of like machine learning models. And depending on the problem I have, I might choose to train 3 different models and look at the performance of each of them, and then decide, okay, based off of like the performance in terms of like accuracy or whatever my metric is, and also in terms of like complexity to deploy this model, and in terms of like actual resources I would need from a computational perspective to deploy this, then I would decide which of those models I actually want to deploy to a production environment. And then I would sort of go through that implementation process. And then you kind of have to build in like a feedback cycle. So the machine learning life cycle never ends. Like, as soon as you put a model in production, it's out of date. It starts to drift, right? Because your data changes over time.
That makes sense. I was going to ask, how do you know, like, if you have enough data to be accurate with, like, go back to your CAPTCHA example, like if you're looking for pictures with crosswalks in it, clearly like collecting that data is a very manual process. So you have to figure that out. But then how do you know when you have enough data to...
So, I mean, there are like interpretability, like, I think a lot of this is also still very academic, but there are ways to, like, I guess, introspect or inspect your data to see if like how well it's doing. But you'll always identify like failure modes. I think there's like some classic examples out there. I think when I had like first started reading about machine learning, there was some model from Google. I can't remember the name. It was like a vision model, but essentially they like had a way where they could look at what this model like thought a dumbbell was, like an actual like dumbbell weight. And when they like went through this like inspection process, they realized that their model like only classified dumbbells if it like was attached to a hand. because all of the pictures they had of dumbbells were like with a hand attached to it. And so you'll always have like failure modes like that. Like I don't think unless you have like internet scale data, which a lot of these like large language models, there's like internet scale data, and we still find cases where it doesn't necessarily generalize. But you'll always run into these sort of like failure modes, and so that's why it's important to make this like a never-ending sort of improvement process, right? Like if I'm training on crosswalks, maybe I don't have any crosswalks images like when it's raining or like when it's snowing, and so that sort of like occludes the crosswalk.
Yeah, that makes sense. It kind of like you're accidentally just creating biased data, like especially like with your dumbbell example, it only recognized the dumbbell with a hand.
Yep. Yeah. I mean, sometimes like, maybe like having biased data is actually like a good thing. And not bias in terms of like, bias, but like if your data is biased towards like the distribution that your customers belong in like a certain way. So like maybe a good example of this is like, I don't know, like health models. Like if I'm trying to predict if someone has like, what their chances of like developing like heart disease are, right? Like if I only train on like healthy 25-year-old adults, like, and so then like their percentages of having like heart disease in this data set, like is basically 0. I train a model to like always predict that no one is at risk of heart disease, then that's a very bad thing, right? So sometimes it's good to have data that is not necessarily like biased, might not be the good way to put it, but like you want representative data. So like data that actually represents the segments that you care about.
That makes sense. So I know like in your book, you talked about, now correct me if I'm wrong, I think it's Bumblebee, right? But Bumblebee is like large data models, right? Or am I off? Is that okay?
So Bumblebee is like they're pre-trained models, and a lot of them do tend to be pretty large.
Okay, and you kind of discuss how you can take the large data model and break it down into your use case, whatever you may need, where it might just be a piece of that data model. How often, like when I'm using Bumblebee, like what kind of data model am I looking for? Like, how do you even know what you want to use for a specific project, like for our crosswalk project, for example?
Yeah. So like, it's kind of a toss up. Like this is like choosing like deciding which large language model I want to use for, a specific project. Like, do I want to use like Llama 3? Do I want to use like just OpenAI's proprietary models? Sort of like the same decision-making process. Like one, you could just evaluate on whatever your task is. And like, especially when you're working with large language models, like you need to be evaluating like on your task. Like you need to build evals into your whatever your process is, regardless of like which models you're using. Like evaluations are probably one of the most important parts of like the machine learning process, right? Building in like robust like evaluations so I can look at how a model is performing on metrics that you care about. You could also just like if you're like deciding like I want to fine tune one of these pre-trained models, because I think that's what you're referencing in the book, is I can take a pre-trained model and then adapt it to my use case. So if I have like a very generic like vision model that was trained on 1,000 different classes, it can predict 1,000 different classes, and I want to adapt that to only predict like crosswalk or not crosswalk, because we're building like a jaywalk detector or something. So I could basically take any of those pre-trained models more than likely and just like adapt that to my specific problem. And
we could always do the Silicon Valley example, hot dog, not hot dog.
Yeah. I've actually never seen that show, but
oh my gosh, you have to. It's probably one of my favorite shows I've ever watched.
I'm a big Netflix and streaming person. My new one is Desperate Housewives right now.
There you go. That's I wouldn't expect that one, but hey, man.
Yeah.
Okay, I kind of forgot where we were now.
Yeah.
I distracted myself with Silicon Valley. Oh yeah, large, like breaking down, like reusing large language models. Now, when you're determining if your evaluations are working, is that always completely manual? Like, is there any automated tasks you can do on your own like LLM or whatever you're training?
I mean, like it can be manual, it can be an automated process. Like if I'm trying to detect like certain like failure modes in a large language model, like in production, there's stuff like you could probably like explicitly look for and like automate. And then for like the actual evaluation process, like the generation of like evaluation based data could also be like an automated collection from like customer feedback. So like maybe good examples like ChatGPT, you can provide corrections or like choose which one is better than another. So that could be like a good example of like an automated like feedback collection cycle. And then I use that data to like actually construct an eval. And then you sort of have that like feedback loop of continuous improvement. It could also be manual where you actually have like, uh, someone sitting down and looking at like queries and saying like, okay, this is what output I got on this input. And, now let's manually correct that. But I guess if I describe it in that sense, it's manual a lot of the times. It's just like at what level is it manual? Like, am I lifting that like manual annotation to like the customer, or am I doing it like on the back end?
Mm-hmm.
Um,
Well, as
and
far
so
as accuracy goes, it's probably better to do it in-house versus depending on, like, look at ChatGPT. Like, how many people probably purposely give it bad feedback?
yeah, I think I've done that before.
Yeah. Or you could just have your nice like machine learning or AI implementation like Amazon does, and just hire low wage
Oh yeah, the Mechanical Turk.
employees to suggest products to their customers.
Yeah, I think it was Mechanical Turk or yeah. Amazon's recommendations are also not great. I don't know what they're doing there, but
Yeah.
sometimes I just want to buy things, and Amazon does not do a great job selling.
I know. You just have to talk with your phone present with like Instagram up, and then you'll start getting the products you're looking for.
Yeah. Actually, that's funny because I like just started golfing, and now all of my like I get recommended so many golf products, and I don't know how they know that I'm golfing. Like, I don't search golf things, but I went to a driving range a couple of times, and now it's like, all right, here's all of these golf gadgets to fix your swing.
Oh, it's tracking you.
Yeah. Yeah.
Golf is a sport I don't have the patience for. I'm like good for like 6 to 8 holes, and then I'm ready to go.
Yeah, I haven't been to actually play like around yet, so we'll see how it goes. I remember when I like probably eighth grade was when I tried once, and yeah, same thing, couldn't do it. It was like 3 holes, I made it, and then let's go
And
home.
then you just hit that age where you have to golf, huh?
Now everyone's golfing, so I feel
Yeah.
like I have to get involved. I'm maturing.
That's funny. Um, all right, I have a list of things here. We talked about tensors, gradient descent. What when you speak of like loss functions, what does that mean?
Yeah, a loss function is so loss function and objective function. Uh, you can basically say they're like equivalent. They are a measure of like how wrong your model is on a certain input, or you could say how correct your model is. But usually, when I am looking at like let's say a classification problem, the metric that I care about in a classification problem is probably accuracy, right? Like how, and that could be top 5 accuracy, it could be top 1 accuracy. It's just like a raw, like, percentage, how correct am I there? The problem with accuracy is like I think you call it like a sparse metric, which means like I don't get a lot of feedback in terms of like gradient propagation from the accuracy metric. So like it's hard to optimize a model, specifically like a deep learning model, for accuracy explicitly. So I choose a different loss function, which is it's kind of like an auxiliary loss function, or it's like it essentially like if I choose the correct like loss function, in this case, I'm using what would be called cross entropy, and that will if I optimize that cross entropy loss on my like model's parameters, or optimize my model's parameters on that cross entropy loss, it will implicitly optimize for accuracy. So your loss function, it's like the same thing as objective function, and it's how wrong are my model's predictions.
Okay. So that's probably pretty useful with making things more accurate, and that's a little more is it a little more automated when you have your loss functions?
So if we're talking about like large language model evals, right? Or
Yeah.
so usually your a lot of people when they're building like large language model based applications are not like training their own models, right? So they're implementing like either like RAG retrieval augmented generation pipelines, or they're like prompting models in sort of like unique ways. So those evaluations usually won't use like a loss function. Like when we reference like loss function in terms of machine learning, usually you're talking about like training your own model on some metric, some objective function.
Okay. So like an example of where you wouldn't use it would that be like a typical situation with like what instructor does, where it's like prompting a large language model to give it a specific response?
Yeah, so instructor is like structured outputs, right? So
Yeah.
it's like basically for a lot of these like text generation servers like Llama CPP, whatever OpenAI is doing, they're using more than likely they're using constrained sampling. So when I'll try to like simplify the like text generation process of a large language model here, but basically like when I put a prompt into a large language model, at each like step, each next token, I'm going to get a massive tensor or vector or whatever, but basically a list of like probabilities. And those probabilities will represent the next token that I should predict. And so I could pick, like the next most probable token every single time, and that would be called like greedy sampling. That's essentially saying like, okay, if the next token in the sentence is like cats, then I would choose that because that's like the highest probability. And then I would repeat the process again and just generate the probabilities for the next token and the next token. When you're dealing with something like instructor, a lot of times that's backed by something called constrained generation or constrained sampling. So you can imagine I get the same list of probabilities out, but I want my generation to follow like a schema. So I want it to follow, let's say, a valid JSON schema. Well, like essentially how to generate valid JSON. Like I can tell you at any given point in my sequence what tokens are valid to actually make what I'm generating valid JSON. So I would take that massive list of probabilities, open-ended probabilities, and then I would mask those tokens, or I would mask the tokens that are like generating invalid JSON. And so that's what instructor is doing, or it's like guiding these like text generation servers to do, is to generate valid JSON in the form of the JSON schema or ecto schema that you give it. And then instructor is like you said, it's very useful for building large language model based applications because it sort of gives you like a medium to go from like text to like application code. And I think if you're building a like large language model based application, you should use instructor. It just makes things so much simpler.
It makes sense because you're able to actually like get organized response data back versus otherwise it's just plain text, right? And
and
you're gonna have to sort through that.
Exactly. Yeah. So like it's sort of like, I think a lot of like application building is like just a lot of your time is domain modeling. Like how do I model the problem that I'm trying to solve? And like very rarely do we encounter a problem where like just raw text effectively solves a problem, right? So being able to like actually model our domain in like a structured way with a large language model is very, very, very useful.
Yeah, that makes a lot of sense. Now, I know a lot of machine learning and the learning curve is spent in notebooks. And what are there any like bonuses or any advantages to Livebook versus like Jupyter or other notebooks out there that you prefer working with Livebook over?
Yeah, so I think there are a ton of advantages that Livebook has over like regular Jupyter notebooks. If you like followed like the development of Livebook in like the early days when Jose and Jonathan were working on it, they like actually like they had a very hard look at like what people complained about the most about Jupyter notebooks. And like I think one of the top ones was like reproducibility, which is a perfect example right off the bat. If I give you a Jupyter notebook, like there's probably a 70% chance that it's broken on your machine. So like you pick up my Jupyter notebook and you try to run it, and like it might not work because you kind of have this like out of order execution. When you're dealing with like a mutable language, that can also like throw a wrench in things. Like I could define a variable like in a cell up here and then like mutate it in a cell down here and then like jump to a cell up here and try to execute that. And it throws things off a lot. There's also just like the issue of like global dependencies in Python, which, you know, you can solve with like environments and stuff, but that still kind of is a pain. With Livebooks, you can connect to other like nodes. So I could connect to like my running application and run Livebooks against like my production data, which is very useful if you're doing like administrative tasks. Like, you know, sometimes you might not even need to build like an actual like admin dashboard because I can just do things from like a Livebook. And then I think Kino is like pretty awesome. Like there's a lot of like this concept of smart cells. Like I think Jupyter and certain like notebook forks have the concept of smart cells. But Livebook, it's sort of like built in, it's native to the platform. So I think that's a big benefit as well. There are like 100 other like, you know, benefits to using Livebook. I think if you follow Andres Alejos on Twitter, he's probably the person to talk to Livebook about.
Yeah, I always love his like little Livebook demos that he posts because he's doing really cool projects and he gets them done so quick. I'm excited. I'm having him on, I think July 12th, so that'll be a lot of fun. And awesome. I don't know. I don't use Livebook, and I feel like I'm missing out on a lot. So I need to learn. I need to learn how to do it. And I was tweeting with him, and I was like, after our podcast, we got to set up a live stream where you teach me how to use Livebook.
Yeah, he's like you know, dove into like the building your own smart cells and like a lot of the internal stuff too. That I don't think a lot of people really know. Like I don't really know much about it either. I'm kind of just like using what other people have built with Livebook, and you know, sometimes you feel like you're not taking full advantage of.
I mean, like I've opened up Livebooks like with the Elixir patterns book and like things like that, where I've like compiled like little bits of code, but I don't know how to actually leverage Livebook.
Yeah, so another benefit you get from Livebook too, actually, is the like file format is text based. So if you've ever worked with like a Jupyter notebook, they can be like they can kind of be a pain to version control because it's like a binary file format. So if you are writing a book too, Livebook is a great platform to write a book in, because you can make each of your chapters an actual like runnable Livebook, which has its benefits. Trust me.
Yeah, that's pretty cool. We have a pretty good question that came up. Is there any fine-tuned LLM that doesn't suck on Elixir code outside of Python and JS? They're all pretty weak.
Yeah. So we had explored like fine-tuning an Elixir-based language model or like code model, and I've like messed around with it before. I think the problem is like a lot of them, you just don't have enough like sample data or like Elixir code. Like part of the reason I think, so I have a theory that I think is maybe not a theory. I think it's correct, honestly. But like a lot of language models are really good at writing like library code for really bad libraries or like really bad APIs. So like pandas, like if I have to like open up like a Jupyter notebook and write pandas, which is the Python data frame library, like I actually never write it myself anymore, because you can just ask ChatGPT to do it. And I'm pretty sure that's because like there are probably a million examples of people asking pandas questions on Stack Overflow. Whereas there are not necessarily as many examples of like Elixir code on Stack Overflow or, you know, in GitHub.
Yeah, my experience with like, I've tried to like it. I've tried to like use Cursor and embrace the AI code generation, but I just found myself, I felt like you always get crappy code back and you have to fix it anyways. So you might as well write it right the first time, because it does feel like you're just getting the most popular Stack Overflow response back that isn't ever right.
I used like I've been using an unlicensed Sublime Text since like 2014. So and I don't know if I can switch to anything else at this point, but I did try. I think I tried Zed like for a day, and then I tried Cursor as well, and I was like, I don't really.
I just don't
really need this. Yeah,
I feel like I'm like that that cranky old man that's like, I'll just write my own code.
I'll use ChatGPT for like if I need like a SQL query, like it's usually pretty
Yeah.
decent at like giving you like good, and you can see like, okay, yeah, this is what I want. Like this makes sense.
I also love it for like DevOps stuff, writing like Nginx
Yeah.
configs, and like, because for the most part, those will always be really spot on.
Yeah, make files. I use it for a lot of make files too.
Okay, there you go.
Yeah, like just like the little scripts like that as well. It's
Bash
pretty nice
scripts
for it.
is great. Like I like to automate a lot of my tasks with like a bash script. So if I don't know how to do something, ChatGPT is pretty good with that. But
Yeah.
you definitely can't write Elixir code with it yet.
No, like it could get like schemas, like ecto schemas, if you like define like a model for you. Like there's some little stuff that it could do, but a lot of times you're not going to get like valid libraries out. You're not going to get valid code out.
Yeah.
And then like usually you end up spending more time too, because you're like arguing with ChatGPT about like, no, this is wrong. Like it doesn't, and then it gives you the same code back, and you're like, that is what you just gave me. It doesn't make sense.
Yeah. Or like now, I don't know if this is still true. I feel like you're more in the weeds with machine learning and everything. But like ChatGPT and like other like large language models or AI can't return a non-response. So if they don't know the answer, you're probably just getting something made up. Is there truth to that?
Yeah, like refusals are always sort of like a hard problem. That's what I would call it, like a refusal essentially to respond. And like ChatGPT does refuse to respond in like a lot of cases, right? But it does also like tend to just make something up for you. Like my favorite is when you like ask it a super complex question and like ask it to give you something out. And then, so like a good example of this, I was messing around with in NX, we have like an automatic differentiation like system engine, basically, which is basically just a way to like do calculus. If you've taken like a calculus course, it's a way to take derivatives, but in like higher dimensional spaces, right? And so like we have a way to compute like these gradients automatically in like an actual computation. And so I was messing around with like something in there to implement something called gradient checkpointing, which is like a memory saving technique in machine learning. And so I was like, let's see how good ChatGPT is at this. And so I asked ChatGPT like, hey, can you transform this to implement this like technique? And it's relatively complicated. Like gradient checkpointing is not like a super straightforward thing to implement. And ChatGPT like starts to walk me through the steps, and then like it gave me basically like a function head, and then like a comment in the body that said like, and then you would implement it here, and then like, that's I think my favorite sort of refusal, that it doesn't say that it doesn't know how to do it, but then like it does it for you, and then it tells you, like it makes you finish like the hardest part.
That's funny.
Yeah.
Is there a way to like avoid doing that and just make it respond like, I don't know the answer to that? Or is it hard just off like the functionality of like ChatGPT?
I think,
like it just has a super large data model, right? So it's doing its best to give you a response.
Yeah, I mean, I think you could probably like, if you were like training your own large language model, you could probably like train like specific refusals into it. You could like with prompting, like say like, don't answer like these kind of questions if you don't know. Like if you're doing like a retrieval augmented generation type of like pipeline, it's probably easier to build sort of like refusals into that. Like if I give you references to information and like the references I give you don't pertain to the question that's being asked, like don't answer, just say you don't know. So it's probably easier to like use like prompting in that way, or to fine tune the refusals into it. But covering every single case is like, I think that's sort of the problem that like people are running into, is like just the lack of generalization in a lot of like cases for these large language models. It becomes problematic because you can't cover every single use case, right? So they're very powerful on like a lot of things, but there are sometimes like some cases where it just like doesn't generalize and things fall apart.
Mm-hmm. That makes sense. I mean, you can't cover everything. Everyone has their edge cases, right?
Yeah, exactly.
Well, at least not yet.
Yeah, not yet. Maybe in like 2 or 3 years, but we'll see.
Yeah. With that being said, like what excites you most about the current state and trajectory of machine learning?
Yeah. So I think there's a lot of like exciting things going on in like the Elixir ecosystem specifically. Like I think uh, we're improving a lot of things like just steadily. It's been probably almost 4 years now that I've been working in this space, and like um, just seeing like the consistent improvement from year to year has been very encouraging. And I think like the trajectory we're on, where like I wouldn't say we are on par with like the Python ecosystem, but like we're like closing the gap like every single day. Still early days, and still some like things we need to implement, but I would say we're slowly but surely becoming a more and more mature like ecosystem here in Elixir.
That's awesome.
I think there's a lot of things to get excited about. We've got a lot of like cool things I think coming out in the next 6 months, so a lot of things to look forward to.
Do you see Elixir, being and the community being a big player and catching up and maybe overtaking some of the more popular spaces?
Um, I hope, but I don't want to like I would like temper expectations a little bit. One of the challenges we have is just that like researchers, when they're the people that are like implementing like these new machine learning techniques, they all like learn Python and do everything in Python because that's what academia is sort of like Python has sort of like a chokehold on academia, so that makes it a little bit difficult. Like they're always going to, maybe not always, but a lot of times they're going to be like the model originators. But I think that you will see a lot of like actual production or deployment applications in Elixir. Like I think that'll become a much more common use case. And I've had a lot of people I think that are like starting to build their like machine learning based startups or machine learning adjacent startups in Elixir, choosing Elixir just because of like the benefits of Elixir. And then also like a benefit on top of that is that you could do some of the machine learning stuff, in Elixir as well. I think that like will become more popular as like as a choice because you can do a lot with like a very small team.
Yeah, I think that's what I keep trying to push. If you have a web application, the amount you can create with a one person dev team is amazing. Like when you're using LiveView and Phoenix, turnaround is so fast. And I just started messing around with the Ash framework this last week. And that's also another powerful tool to add to your arsenal to keep your team small.
Yeah, I started messing around with Ash right after Zach and we did a talk, the Elixir Krakow meetup. Maybe it was like last month. I started messing around. I was like, oh, this is actually pretty nice.
That's
So
awesome.
and the thing is too, like I would say like there's still like benefit like things coming out in Elixir like every single day. Like Flame was 6 months ago at this point, and that's like a pretty sweet library to use. And like Oban is awesome. There's just a lot of like things we have in the ecosystem. People complain about like lack of libraries, lack of like not every library you use has like long-term maintainers or whatever. But I think like you can do a lot with Elixir regardless of the lack of libraries. I think like sometimes the lack of libraries might be like a benefit.
Yeah, like, oh my gosh, write your own code.
Yeah. Like you don't have to, it sucks you can't just like import something and do like one line here. But a lot of times like when you're like building a complex application and like you have to take like the training wheels off, some of those libraries can actually like hinder you. Whereas
For
if you just
sure.
implement
Well,
it,
and then look at the bloat of JavaScript applications too. You can't start
yeah,
a React project without like 50,000 dependencies.
yeah,
So
yeah, exactly. And I think there's a lot of benefits to choosing Elixir.
yeah, I agree with you. So with you being so deep in the space for machine learning and AI, all this stuff, what do you actively research and what resources are you using to stay on top of things?
Yeah, I mean, I spend a lot of time on Twitter. It's like a lot of like papers will come out on Twitter, and I'll see some like things there. Um, for a while, like especially in the early days, I would monitor PyTorch, which is that's Facebook's or Meta's deep learning library. They actually have like a dev discuss forum where they actually have like the PyTorch maintainers and people from other large companies in like that have an interest in PyTorch, and they'll come together and like talk about like different, I guess, changes to the framework. So as like a machine learning framework maintainer, that's always been very interesting to me to see sort of like where that ecosystem is going. And then like OpenXLA, which is the compiler that we use for Nx in a lot of cases, the EXLA, that's what EXLA is built on. They actually have like a community, like Google group discussion page, so people come in and ask questions, and I get a lot of updates from there. And then sometimes I'll just go on archive and sort of see like what new papers come out. And like one of the benefits I think of our ecosystem is like we kind of I guess we get to decide like what to work on. We're forced to decide, obviously, like what we want to implement and what we don't want to implement, because we don't have like the manpower to like go out and actually like implement every single technique that's out there. So I guess one of the benefits of like being downstream from all of the like innovation that's happening is we can sort of wait for some of the more modern techniques to like actually establish themselves as like, yeah, this is something that's really useful. Now go and implement it. And like the development like pace, I think, for our working in Nx and some of these frameworks is pretty quick too, just because like we have a pretty good foundation. So like one of the benefit or problems that like PyTorch had, they sort of like rewrote a lot of their infrastructure. Was a lot of their like internals were written in C++, and so like they had a Python front end, but a lot of like the compiler internals and everything were C++, which is it can be a lot harder to maintain, especially depending on like the size of the project. We, from the beginning, essentially every single one of our projects was 100% Elixir, aside from the actual like machine learning compiler we were using. So there was only really one like layer of our ecosystem that was like a native library. And then everything else you wrote was an Elixir, but you got the benefits of like the speed ups of a native language, right? So that really, really helps like from a development velocity standpoint, because everything we're writing is just Elixir code.
Yeah, that's awesome. I love that. When you have people approach you, and like my channel has a lot of new Elixir developers in it, what do you recommend if you're interested in machine learning and even contributing? Where should people start to learn, and where can they find the most beneficial information for the Elixir community?
Yeah. So I think like docs and learning material are like one of the things that we're sparse on. So my first recommendation would be, and like as I said in the beginning of this live stream, like I learned things by writing like things, explaining things to people. So I think a good place to start is just like help with documentation or writing examples, or like writing tutorials explaining how some of the things work to other people. Because like one, that would be a massive benefit to, I think, all of the maintainers, where like just having more learning material out there for people that are entering the ecosystem. And then two, you kind of get the understanding of like how some of these things work. I think examples is like another great like opportunity for people to like just get started and contribute. Like both Scholar, Axon, I think even Nx, like we have like not open issues, but like we would accept like examples of how to use different portions of the library. So like Axon specifically, if you went and looked up like Keras examples, Keras is a Python deep learning framework. If you looked up a Keras like example, and you'll find the website for Keras examples, and it'll have like a step-by-step of how to do something in Keras. If you took that example, translated it to Axon, I would accept that right away as a part of the documentation, because having more examples of like how to do things in Axon is obviously a massive benefit. And I think
there you go, guys. That's an easy way to be a contributor too.
Yeah, that would be a massive help to me too, because if there's something that like, if there's an example you find that can't be done, then it like finds a shortage like or a gap in the framework. And then if there's something confusing, like same thing, helps with the documentation. And then just having that example around is a huge help for other people that are trying to do maybe the same thing as you.
Yeah, I love that. Now, you got to plug your book a little bit. Let's tell us about your book first of all, and then what your hope is to, what you're hoping the reader takes away from it, and then where can people find it?
Yeah, so my book is Machine Learning in Elixir, and it is meant to be like an introduction to a high-level introduction to like everything you would encounter in the machine learning ecosystem. So my hope for that book is it kind of serves as like your start on any sort of like machine learning journey. So you don't need to know anything about machine learning. I don't really even think you need to know anything about Elixir to read the book. And after reading that book, I would assume that if you wanted to go much deeper into the machine learning world, that you would have the knowledge that you would need to do that. The book is on the Pragmatic bookshelf. It just went to production. So if you are a fan of print copies, you can get a print copy from Amazon, I think sometime soon. I don't know if it's out yet, but it should be sometime soon. Or you could buy the digital copy off of the Pragmatic.
Does that mean
bookshelf.
it's out of beta?
It is out of beta.
Sweet.
Out of beta is kind of like a relative term because a lot of the libraries we have are pre 1.0. So if things do
Fair
change,
enough.
I sincerely apologize. When I took on this project like 2 or 3 years ago, I was talking to Jose a little bit about it, and he told me how much of a nightmare it is to write books about your own libraries, because the second you make a change, your book also gets out of date. So you have to update like 4 different places. And I definitely did not feel the pain at the time. And 2 years later, I know exactly what he was talking about.
Dude, I'm telling you, I couldn't do it. So kudos to you for being so awesome and producing great content too. I love that. It looks like we have another decent question here. Have you looked at the MLIR compiler that modular, why can't I say that? That Mojo has?
Yeah, so the founder of Mojo, Chris Lattner, he's the guy that wrote LLVM. He also is the guy that was originally behind the XLA project. And then recently, the OpenXLA project actually migrated to MLIR, which is like middle level intermediate representation or something like that. It's basically like a compiler infrastructure. If you go look at the EXLA repo, you'll actually see we migrated to MLIR. That was Paulo Valente did that very recently. So we have like fully integrated basically with MLIR, and I think we're using stable HLO as our like dialect of MLIR. So we're getting essentially all the benefits that that Mojo is getting from MLIR as well.
That's awesome. Cool. If anyone else has any questions for Sean right now is the time. And then other than that, we're going to just probably close this up because Sean has a tight schedule.
Awesome. Yeah. Appreciate you having me on, and I appreciate the questions.
Yeah. Thank you so much for coming on. And every time machine learning people, I have so much to learn in life. I feel so behind, but it's cool. And one of these days I'm going to take the time and start implementing machine learning into a project just so I start to learn, because I'm a hands-on person. I don't really understand things until I dive in.
Yeah. And hopefully things are easier now with some of the improvements we've made to the Elixir machine learning ecosystem.
Yeah, if you have any project ideas that you'd like to see like made into tutorials on my YouTube channel, let me know, and I'll
yeah, I think I've got a few actually. Yeah, I'll send a few to you.
All right, cool. Because I know everyone would appreciate if I started doing some machine learning tutorials.
Yeah, it'd be awesome too to have some extra material out there. So
yeah, for sure. All right, well, everyone, thank you for tuning in. That's Sean. Awesome that you were here. Thank you so much for joining me, and I'll see you guys in the next live stream. Testing.